Hey, I'm Steve. I'm going to do a quick tutorial on using Swift to make a very simple blockchain. I found it just helps understand the fundamentals of how a blockchain works. If you're handy with code, it's a fun little thing to make and you can play around with it, mess with it and see how it'll correct itself. So what we'll do is just use Playgrounds in Xcode, just because it gives you live updates of what's happening, live values, and it's just super easy to work with. So we'll jump in, get started with Playground. Just a blank canvas. I'm going to call mine Steve Coin. You can call it yours whatever you like. Create that. We can get rid of this string and we can get rid of everything above there. So what I'll do here is I might just try and explain graphically with a little picture here. So a blockchain is literally a series of blocks and they are all sort of connected in a chain, so it just helps it realize when something goes wrong. It can refer to the previous or the block ahead of it and check that things are right, or if things are being tampered with, and so on. So it would sort of look like that. For this tutorial, I'll just use floor blocks. Kind of, it's plenty to understand and see what's going on. Too many and it might just get a bit crowded. So that's more or less what it looks like, and within each block you've got a bunch of things. So each block also has an index. So say this one, it's called the Genesis block, the very first block of a chain, and its index is 0. This one, it'll be index of 1, this one 2, and this one 3. So that's your indexes. You're going to have a hash key for each, and that is more or less just a unique identifier. The hash key is made up of all the data in the block, and then so each hash key will be unique, whether it includes timestamps, information, transactions, previous hash keys, and so on. So the hash key is just a unique ID. Typically, in the cryptocurrencies, I'm pretty sure they look something like anything like that. Ours will be a little different, and we'll just use a little function to generate a random one. You're also going to have your data. So for ours, we'll just do a string for our data. You could make a class and have all the different variables of data, being times, from, to, amount, all that sort of thing. But for this, we'll just do sort of from someone to someone, and then we'll have amount of however many coins. So another thing that will be in there is the previous hash. So this is just the hash key of the block before. So if we were looking at the previous hash variable in this block, it's going to be the hash of that block there. So previous hash is a unique ID of the previous block. Then we've got the index. That's what's going on up here. We'll just put a note here, index. Then that's about it. I might just put a note here for what a Genesis block is too. So Genesis block is the first block in a chain. So it has no predecessors or any. So what I'll do is just make a quick sort of structure of how I'll go about this. So I'm going to create a block class to start with. Then I'm going to do create a block chain class. Then we'll do, maybe after that we can just create a chain. Create a chain. We can have an area where we'll tamper with the data, tamper with chain data, and just see how it we'll make like a little function then that checks the validity of it, of your chain. So that'll tell you when something's not right, someone's playing around with it, trying to make millions. So we'll start with creating the block class, which is It's a very small little class, so we'll go class, and we're going to call it block, and within your block, you're going to have variables. So each block should have a hash key, variable hash key, and that will equal a string. Each block will have a data variable, and that for us is just going to be a string. This is where if you were going to be a little bit more techie, you could make a class of data, and that's going to have all the variables that the data should have, and then you just say variable data equals the data class. And then you'd have to go through and initialize all of them as well. So then we'll have also a variable of previous hash, and that's just going to be a string. We'll have a variable of index, and that will be an integer, because you're not going to have a double, so you're not going to have 1.0, 1.1, you're just going to have 1, 2, 3, 4. So that's pretty much what the block class is made up of. We'll also just include a function in here to create our random hash key. So we'll say create hash, and it's going to return a string. So I might just go down here and show you what we're going to use. We'll say let I equal, and there is this function nsuid dot uuid. Oops, what have I done? UUID string. Let I equal ns. Okay, we need to put the brackets there, and then UUID string, and that should just give us a big random string. Now we'll just clean this up. Return. We'll just some string for now. So let I equal, okay, so this gives us a random string here. There's no guarantee that it's not going to repeat itself, apart from we're only creating 4 for now, so it's just not going to happen. But you could make a function where it's a lot safer. It could check, you could make an array of all the ones you have created and check that it doesn't create an existing one. Alternatively, you'd make your hash keys really should be composed of all the elements in your block, so it will be unique every time. So I'm just going to get rid of the dashes in there, replacing occurrence of the hyphen with just empty. Okay, so now what I can do is take that and return that instead. So now we have a function to create a random hash key. Okay, so that's the end of our block class. So next we'll make a blockchain class. So class blockchain, and this will have 2 different functions, and it will have a function for creating a Genesis block. Create a Genesis block, and we're going to pass in the data of this transaction, or this block, what's going on in this block. So just as a string, and it will start with let gblock equal block. So now we've created the first Genesis block, but we need to add all those values, initialize all the values of these ones. So we'll say gblock dot hash equals gblock dot create hash, and we'll say gblock data equals data, because that has come from when we created it. Then we'll say gblock previous hash there is none, because it is the Genesis block. Okay, and then it's going to have an index of 1, 0, because it's the 0th block. It's the very first block. So once we've done that, we want to append it to our chain, but we haven't got a chain yet. So we'll go back up here and we'll say variable chain equals block. So we've just created there an array of blocks. So more or less that picture up the top there, that's what that is, an array of blocks, but there is no blocks in that yet. So now that we have that, we can then add this G block that we've made, the very first block. We can say chain.append, which means add to, and we'll say G block. So that is all there is to your Genesis block, and then we're going to make another function, which is add a block. So this one will be very similar, except a little bit more universal, because it's the skeleton, I guess, of all the blocks following will all follow this same sort of structure. So we say function add block, and we'll say let new block equal a block, and then we'll go through and populate all its data. So we'll say new block dot hash equals new block dot create hash. Yes. So new block data equals data. Now we're going to do new block dot previous hash. So what we need to do here is look at our chain and how many elements there are in it. So we'll say the chain, and then so we'll go to chain. We're going to count how many are in the chain. So chain count, chain dot count, and then we're going to take away 1. Just give that space. So chain count. So when we've got one block in there, the Genesis block, it's going to say there's one block in there. So when we get 1, we take away 1, and we get 0. So then new block dot index will equal chain dot count, because the index for the first block will be 1, because the index for this one was 0, but chain count will return 1 because it's already 1 in there. So that will work for each block. It will look at how many there are and use that number. So then we say chain.append, we'll say new block. Alright, so that is the blockchain. Now we will go and create our chain, and I'm just going to call mine Steve Coin. Steve Coin equals a blockchain. So now I've created a blockchain, and you can see once it loads up here, it's just an empty array of blocks. There's nothing in there. So now we can add our Genesis block. We'll say stevecoin dot create Genesis block, and the data that's going to go in for this. So because we're just going to use a string, we'll just say from person A. We'll say from person A to person B, and then we'll say amount. So person A sent 10 Steve coin to person B. Yeah, 10 Steve coins. So now our chain has its first block in it, and it has data. So from that we can now add more. So we'll go add block, same thing. We're going to use this little format here, and we'll say from person B to person C, and they sent 8 coins because because they weren't feeling as generous. So we can do that a couple more times, and we'll just change these from person C back to person A. They sent 25 coins. And we can go person D sent to person C. We can say 17 coins. So now we have a blockchain, and it has 4 elements in it, 4 different blocks, and they all have their own data about them. So you could look at any block in there. You could say stevecoin.chain. We can look at the second coin, and we can say dot. We can have a look at the data. That should tell us from person C to person A amount 25 Steve. So that is exactly what it says here. So that's how that works. Now we can go down here. We might first create this area down here, which is just gonna run a simple little loop to check if the chain is still valid. So we'll say var is chain valid, and we'll just set that to true for now, because assuming the chain's never been tampered with yet, it's only just been created. We'll say for I in 1 to stevecoin dot chain dot count -1. So that goes from 1 to 3. I think that should be from 0. From 0 to 3, we're going to say if stevecoin dot chain I, the ith value, previous hash is not equal to stevecoin dot chain I -1, so the previous block hash, then something's wrong. Data's not matching. The block that we're looking at, the previous hash, what it thinks is the previous hash is not actually the previous hash. So someone's been playing around with things. So we'll say is chain valid, and that will equal false. After all that, we can then just print. We can print and say chain is valid, and is chain valid. Okay, so we do need to have 1 because we're checking the first block. We aren't checking the genesis block because it doesn't have a previous hash. The previous hash is nil, so that's why it should be 1. Yeah, so 1 to the amount of coins. So we're just checking all blocks after the genesis block. So is the chain valid? True, it is valid. So now if we go up here and we play around with, say, the third block, so index of 2, we'll say stevecoin dot chain, and we'll say the second block dot hash equals something else. Make me rich. Yeah. So now the chain isn't valid. So what we want to do, we might actually just add in another one here. And we'll say print chain data. So we'll say, just using another for loop, we'll say for I in 0 to stevecoin dot chain dot count -1, and we'll go through and just print out all the data for each. So I'll say print. We're gonna have, we'll just give it a \t, that's a tab. So \t block, and this will tell us which block it is. So we'll say Steve coin dot chain the ith value dot index, and then we'll go \n, so that takes a new line, \t brings it in again, one tab, and then we'll say hash equals, and then the same thing, so this but hash, and then again and again, so n t, instead of hash we'll do previous hash, and previous hash should be previous hash. Okay, and then same thing again, /new /t, and we just want to see the data that that block is holding, so we'll put the same thing dot data. So now we might want another n after that new line. If we have a look at all our data down here, we can see that block 0 has got the hash key, previous hash there is none because it's a Genesis block. The data from person A to person B amounts to 10 coins. So the one we messed with was this one. So we said the hash is now make me rich. But if we go to block 3, it says the previous hash should be this. So they don't match, and then that's why it shows false. So that's how to make a very simple blockchain. All the basics, just absolute fundamentals. You can play with it, make it bigger, more secure, do whatever you want with it. Hopefully it's given you a bit of an idea and you can have a bit of fun with it.